All right, so in the last video, I defined greatest common divisor, GCD, and in this video, we're going to define sort of, in some ways, kind of the opposite of that, kind of, which is the least common multiple. I would call it less. I would actually use the word dual, but we haven't really talked about dual yet. Look up what dual means, D-U-A-L. Anyway, the least common multiple is similar to a GCD, and it's defined quite similarly, but it really is not a, it's not a divisor, it's a multiple, right? So it's kind of things are flipped around. You take two numbers, A and B, the LCM, least common multiple of those numbers, is the smallest integer m that A and B both divide, right? So instead of m dividing them, now A and B are dividing m. So it's flipped around. So yeah, I mean, it's right in the name, right? If A divides M and B divides M, then it means M is a multiple of both A and B, and it's the least common multiple of A and B. All right, so let's look at an example of that. Let's look at the same two numbers we looked at last time. So 1,540 and 490, right? What's the least common multiple of those numbers? Well, again, I'm going to write out the prime decomposition of those numbers. It was 2 times 2 times 5 times 7 times 11 for 1,540. And then for 490, it was 2 times 5 times 7 times 7. And instead of looking for overlap here, what we want to be looking for is more of like a union. Instead of an intersection, it's more of like a union of these two things. So we can take at least two 2's, all right? Because we're gonna have how do I draw this? It's like we can take up to two 2's, okay? It's sort of what can we get instead of what's the minimum? It's more like what's the maximum? We can take 1 5, okay, up to 1 5. We can take 2 7's, right? And we can take this 1 11. So what we're going to get from that is 2 2's and a 5 and 2 7's and an 11, like that. And that, I'm going to put a red box around that one. That gives us the number 10,780. So we have these two kind of opposing ideas, greatest common divisor versus least common multiple, which is kind of confusing because the greatest common divisor gives you a smaller number, and the least common multiple gives you a larger number. But remember, greatest but still less, and least but still more. That's kind of the idea here. So now, let's take a look at a theorem related to these two. The theorem says that A times B is going to equal the greatest common divisor of A and B times the least common multiple of A and B. And that's it. That's the theorem. And so in our example, it turns out if you take 1,540 and multiply that by 490, well, what are we going to get? We're going to get 2 times 2 times 5 times 7 times 11 for 1,540. And then multiply that by 2 times 5 times 7 times 7 for 490. Now just rearrange this and you get 3 2's, 2 times 2 times 2, and then 2 5's, 5 times 5, and then 3 7's, 7 times 7 times 7, and then 1 11. That's going to be the product. Looking through here, remember our green box was 2 times 5 times 7, so that's going to be a 2, a 5, and a 7. And then remember our red box, that was 2 2's, so 2, 2, and then 1 5, and then 2 7's, 7 times 7, and then 1 11. And there we go. As you can see, and this is not a proof by any means, this is just an example. But as you can see there, we have, in the product of these two numbers, we have the entire greatest common divisor in green, and we have the entire least common multiple in red. And so that can be written as 70 times 10,780. And that proves it. Or not doesn't prove it. No, it doesn't prove it. It's just one example. But that does demonstrate it.